Okay, predict all the possible products for this reaction. That seems like a simple consideration to make. So let's take a look at it. What's going on? Okay, so my reactant is DBN, and so I have to remember that DBN is a base only, and so that means since it's a base only, it will be E2 reaction mechanisms that are in play. Okay, so if I'm thinking about an E2 reaction mechanisms, then I want to look at the beta positions because those are the two positions that have hydrogens that I'll eliminate from. Remember, E2 means that the hydrogen is transferred at the same time that the leaving group is leaving, and that was what forms the double bond. Well, I've got two beta positions, but here's where the complication for this particular reaction comes in. At these beta positions, the highlighted blue and the highlighted green, there is only one beta hydrogen. And so that means that we have to make a little bit more of a significant consideration. Because there's only one beta hydrogen, the requirements of an E2 reaction mechanism dictate that the beta hydrogen and the bromine leaving group become anti-paraplanar to each other before the E2 mechanism can take place. So if I have a situation where I only have one beta hydrogen, then I have to consider the rotational conformation that leads to the anti-paraplanar positioning in order for the E2 mechanism to take place. Since there's only one beta hydrogen, that's what I have to do. And in order to consider rotational conformations, I need Newman projections. So I'm going to look down two different bonds to do two different possible Newman projections. Now, I can look down the bond that involves the leaving group, or I can look down the bond that involves the beta hydrogen. It doesn't matter which one I pick, as long as I'm consistent with my drawing. And at the end of the day, the leaving group is anti-paraplanar with the hydrogen. So I'm going to go ahead and pick the direction to look down the bond that starts with the leaving group. And that means the leaving group will be in the front and the beta hydrogen will be in the back. So I'm going to have two situations that I need to consider for Newman projections A and B. And so the next thing that I want to do is figure out, do I want the Newman projection to look like this, or do I want the Newman projection to look like that? So I have two choices, and it doesn't matter, rotations around single bonds can happen, so it can be either direction, but I want to pick the direction that's convenient to me. What I notice when I'm looking down A and I start with this carbon, I'm looking and I see a bond that goes down from that direction. So that means that I want to go ahead and use this particular version of the Newman projection. Well, what about for B? When I look down the bond for B, I see a bond that's also going down. And so in that case, I want to use the same Newman projection that I did before, or for A. And so I want to use this version of the Newman projection as well. All right, so now that I figured out which version of the Newman projections to use, I can go ahead and draw out my back bonds. I'm going to get rid of some clutter up here, and I'm going to go ahead and start with the A direction, and A was this one. Okay, so what do I have in that bond that points down? Well, I had this 3 carbon group, 1, 2, 3, and I had a 5-membered ring off the wedge looking like this. Okay, now that I've done that, let's put everything else where it is. Well, what do I have that's going to the right? And what do I have that's going to the left? Well, when I look down this bond for A, I identified what's going down, but what direction does that bromine face? Is it left or right? Well, bromine's on a wedge, so that means it's coming towards me in the picture above. And if I rotate that picture above, then bromine ends up here. And so that means that hydrogen is there. Okay, well, what about at the beta position, the position in the back? Well, in the position in the back, it looks like I've got a methyl group that's going to be either right or left. And above, I've got my benzene ring. So I can draw the benzene ring going above. And now let's put the methyl group in the right location. If the methyl group is pointing away from me, that means when I rotate it, it'll be on my right. And so here we are. We've got our leaving group, and we've got our beta hydrogen, but we have a problem with that. Our leaving group and our beta hydrogen are not anti-paraplanar from each other. So that means that I need to consider a rotation where they are. And so I need to rotate that hydrogen around and get a configuration where they are anti-paraplanar from each other. So I'm going to actually copy this. And what that means is that I'm going to need to erase what's going on in the back and redraw. So I had one rotation. And so with that one rotation, that means that the benzene ring is now over here. Now my hydrogen is here and the CH3 group has moved up to this position. Let's see if I can show everything at once. So I have my bromine and my hydrogen. They're now anti-paraplanar from each other. Okay, and so this is how I consider how the double bond forms. I'm going to just move this over just a little bit over to here. And so I know that a double bond forms across down this direction between the front and back carbon. And so that means there's going to be 4 groups on that double bond. And what I do is I say, okay, look, I'm going to have my front carbon, that's this one. And then I'm going to have my back carbon, which is this one. And then I want to just say what groups are connected to what. So how does the stereochemistry end up? Well, what do I have on the front carbon? On the front carbon, I have a hydrogen, and I have this 1, 2, 3 carbon group. And I have the 5-membered ring here. Okay, well, what's on the back carbon? Let's take a look. In order to get the stereochemistry right, the CH3 on the back carbon has to be in the same direction as the hydrogen. And that means that the benzene ring has to be in the same direction as this other group, this other big group here. And so that means they're on the same side of the double bond. And so here is one of the structures. Okay, now what I want to do is I want to go back and I want to do the same thing for B. And so when it comes to B, I'm looking down the double bond in this direction. So I've got a similar situation with a big group that goes off this way, and I've got a methyl group that moves towards the back there. And now let's look, which direction is that bromine coming from? Well, the bromine is coming towards me, but when I rotate it this direction, that means the bromine rotates over to here. That ultimately then means I have a hydrogen there. Okay, so what about in the back? In the back, I'm on the same side as the bromine. I'm going to have one, two, three. And I'm going to go ahead and do this a different direction. 1, 2, 3. And I've got 5-membered ring that goes over here. I have the let me back that up. I did that wrong. I've got the same direction as the bromine, I directly go to the 5-membered ring. And in the back, I've got an ethyl group, and that means the hydrogen is here. And so in this case, I see that the beta hydrogen and the bromine are already anti-paraplanar from each other. And so that means I'm going to have another structure. So I'm going to move down the page. I'm going to have another double bond that's going to form along that plane. And I'm going to have 4 groups attached to it. And what I can do is I can start off with the front carbon. Let's go ahead and call the front carbon yellow and the back carbon green. So front and back, like so. And so what's happening in the front carbon? I'm going to have an ethyl group. Excuse me, on the front carbon, I have my benzene ring. And the CH3 group. And what else do I have on the front carbon? On the front carbon, I have a hydrogen. Okay, on the back carbon, I have an ethyl group. And I have this 5-membered ring. And the ethyl group is on the same side as the 5-membered ring. And the 5-membered ring is on the same side as the benzene ring. And so let's go over here to the hydrogen. Let's put my ethyl group there. And then on the same side as the benzene ring, I'll put my 5-membered ring. Okay, I know that was a lot of work, but we ultimately got our 2 elimination products, E2 elimination products. They're just a little bit different from each other. And so here they are. Remember, we have to use Newman projections to sort them out.